Okey. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Uh, so you guys can hear me? Can you confirm on that? Boleh dengar? Okay, thanks. Thank you. Okay, kita start lah. So nanti saya record benda ni, nanti saya upload lagi. Tapi siapa yang masuk, continue lah. Lepas tu. So basically, kita cuba habiskan slide modul nombor 6. So basically section number 4 is about container services. So this container services ialah satu servis yang sekarang ni agak demanding and sangat praktikal, sebab nanti kita tengok kenapa dia sangat praktikal sekarang ni lah. Alright. So container, what definition of container. So basically, containers are a method of operating system virtualization that enables you to run an application and its dependencies in a resource isolated process. So by using containers, you can easily package an application's code, configurations, and dependency into an easy to use building blocks that deliver environmental consistency, operational efficiency, developer productivity and version control. So selalunya yang saya cerita kat kamu dulu macam contohnya bila kamu develop program, selalunya kamu develop, contohnya kamu develop dekat localhost. Localhost maksudnya dekat PC kamu lah kan, selalunya kan. So dekat PC kamu, PC kamu dia ada environment dia, dia ada OS dia lain, dia punya architecture pun lain, so dependency dia pun lain. OS pun mungkin a little bit different. So bila dekat komputer kamu test dia jalan okey. Isunya ialah bila kita nak deploy. So deploy, so the term is deploy. Maksudnya kamu nak bawa that program untuk run dekat dia punya tempat environment, contohnya dekat cloud ataupun dekat data center dan sebagainya. So dia kadang-kadang dia punya dependency, dia punya architecture, OS architecture different. So bila kita run, error. Itu takes time lah. So bila container ni satu cara operating system virtualization, di mana dia macam ambil dia ambil your application, sekali dengan dependency, sekali dengan configuration, sekali dengan OS punya configuration. Okay. So dia macam ambil semua yang make sure dah run tadi cantik kan, letak dekat environment, contohnya dekat the cloud ataupun kat data center. That's the technology lah. So containers are smaller than virtual machines and do not contain an entire operating system. Instead, containers share a virtualized operating system and run as a resource isolated process, which ensure quick, reliable, and consistent deployments. So containers hold everything that the software needs to run, such as libraries, system tools, code, and the runtime. So kadang-kadang macam lah benda-benda ni kadang-kadang kita kena install dulu kat data center ataupun dekat PC yang lain untuk make sure kita punya application run smoothly kan. And then container deliver environmental consistency. because the application's code, configuration and dependency are packaged into a single object. The package tu yang dia namakan container. Dia contain semua yang penting, yang make sure application tu run. So in term of space, container images are usually an order of magnitude smaller than virtual machines. Spinning up a container happens in hundreds of milliseconds. Thus, by using containers, you can use a fast, portable, and infrastructure agnostic environment. So containers can help ensure that applications deploy quickly, reliably, and consistently regardless of deployment environment. So containers also give you more granular control over resources, which give you infrastructure improve efficiency. So dia punya teknologi dia contain, tapi dekat tempat yang dia nak letak pun mesti ada container punya teknologi kan. Kalau tak, macam mana dia nak deploy. Okay. So that's the basic concept lah. Detail nanti kalau kamu nak, sebab sekarang ni on demand lah. Siapa yang expert dalam bidang container, Kubernetes sebab nanti, memang on demand lah sekarang. Okay, so satu lagi dia panggil termsnya ialah Docker. Docker is a software platform that package software such as applications into containers. Okay, and then Docker is installed on each server that will host containers, and it provides simple commands that you can use to build, start or stop containers. So kita nak build container, so kita ada application, so Docker ni software yang build container. So macam mana dia build tu, dia ada cara dia lah. So by using Docker ni, software ni, so you can quickly deploy and scale applications into any environment. So contohnya dekat localhost kat PC kamu, so dia ada Docker, so dia akan contain application kamu based on PC kamu punya requirement lah. Application dan PC kamu punya requirement, contohnya libraries, system tools, code, runtime. So dia ada package siap-siap. So Docker is best used as a solution when you want to standardize environments and then reduce conflicts between language stacks and versions, and then use containers as a service, and then run microservice using standardized code deployments and require portability for data processing. So you run containers on Docker, and containers are created from a template called an image. And container has everything a software application needs to run. So they compile semua yang penting untuk deploy tempat lain lah. Okay. So many people who are first introduced to the concept of container think that container are exactly like virtual machines. So virtual machine pun macam tu lah. Asal dulu kita ada physical physical operating system lah, macam CPU. Lepas tu kita tukar semua ni jadi jadi digital. Dia panggil virtual lah, virtual machines lah, virtual machine. So virtual machine pun ambil space yang besar lah. Tapi however, the difference are in the details. So one significant difference is that virtual machines run directly on hypervisor, but containers can run on any Linux OS if they have the appropriate kernel feature support and the Docker daemon is present. So macam saya kata tadi lah, that teknologi yang support containers perlu ada lah. So dia perlu ada Docker yang daemon tu untuk support teknologi yang Docker buat container tu, and dia ada kernel feature. So, and then this details tu kamu tak boleh tahu lagi. So basically kamu lebih kurang tu lah. So contohnya macam Okay, this makes containers very portable. So your VM, your EC2 instance, and your bare metal server are all potential hosts where you can run a container. So the right of the diagram has a virtual machine. Contoh ni kan, virtual machine 1, 2, and 3. Base deployment. So each of the three EC2 instance runs directly on the hypervisor. So contohnya virtual machine yang kita guna, selalunya dia akan ada ni lah, directly atas hypervisor ni. So dia akan connected sampai ke physical server lah. Each of the three EC2 instance runs directly on the hypervisor that is provided by the AWS global infrastructure. Each EC2 instance runs a virtual machine. In this VM-based deployment, each of the three apps runs on its own VM, which provides process isolation. So basically, macam contoh ni, dia ada EC2 1, EC2 2, EC2 3. So ada tiga benda itu, it's independent. So the left on the diagram has a container based deployment. There is only one EC2. So only one EC2. So yang ni ada EC2 instance. Kan, ada satu je, dia guna satu je EC2 instance. And then there is only one EC2 instance that runs a virtual machines. And then the Docker engine is installed on the Linux gas OS of the EC2 instance. EC2 instance ada OS dia. So they install Docker engine. And then there are three containers in this containers based deployment. Each app runs in its own container which provides process isolation. So EC2 ada satu je. Container application masing-masing akan run atas EC2 dan masing-masing ada environment dia masing-masing. Dia tak terikat pada environment application yang lain-lain lah. So the process that run in the containers communicate directly to the kernel in the Linux gas OS and are largely unaware of their container silo. So dia akan connected dengan kernel yang dalam Linux OS dekat sini lah. And dia ada Docker engine sini ya untuk run this technology. So the Docker engine is present to manage how the containers run on the Linux gas OS, and it also provides essential management function throughout the container lifecycle. So in actual container-based deployment, a large EC2 instance could run hundreds of containers. So katakan ada satu je EC2 tapi dia boleh letak pelbagai application di atas ni. Dia masing-masing run on their own dependency libraries and so on. So dia ada satu Docker agent untuk manage all the containers. So given what you know about containers, you might think that you could launch one or more Amazon EC2 instance, install Docker on each instance, and manage and run the Docker containers on those Amazon EC2 instance yourself. While that is an option, AWS provides a service called Amazon Elastic Container Service. So Amazon ada satu service ni nama Amazon Elastic Container Service that simplifies container management. So Amazon Elastic Container Service, Amazon ECS, is a highly scalable, high performance container management service that supports Docker containers. So Amazon ECS enables you to easily run applications on a managed cluster of Amazon EC2 instance. And essential Amazon ECS features include the ability to launch up to 10,000 of Docker containers in seconds. Okay, dia boleh provide, okay, maksudnya launch tens of thousands Docker container in seconds, and then monitor container deployment, and then manage the state of the cluster that runs the containers, and then schedule containers by using a built-in scheduler or third-party scheduler, for example, Apache, Mesos, or Blocks. And then Amazon ECS cluster can also use a spot instance and reserve instance. Okay, macam mana dia nak guna tu kita mungkin tak nampak lagi macam mana, tapi basically kita basic function tadi kita dah faham. And kelebihan dia boleh multiple beribu tens of thousands Docker containers, so kita boleh duplicate and launch in seconds kalau kita perlukan dia lah. So kita tak nampak lagi sekarang, mungkin kita tak nampak sekarang macam mana dia buat tu dan perlu kenapa kena buat macam tu kan. Tapi tak apa, at least kita dah tahu basic application dan sebagainya lah. So kalau nak guna tu, Amazon juga ada servis ni dipanggil Elastic Container Service untuk buat benda tu. So to prepare your applications to run on Amazon ECS, you create a task definition, which is a text file that describes one or more containers. Okay, up to a maximum of 10. That form your application, and it can be thought of as a blueprint. A blueprint. It can be thought of as a blueprint for your application. Task definition, specify parameters for your applications. For example, which container you use, which containers to use, which ports should be open for your application, and what data volumes should be used with the containers in the task. And then a task is the instantiation of task definition within cluster. So you can specify the number of tasks that we run on your cluster. So the Amazon ECS task scheduler is responsible for placing tasks within your cluster. So a task will run anywhere from 1 to 10 containers, depending on the task definition you define. So when Amazon ECS runs the containers that make up your task, it places them on an ECS cluster. Okay. The cluster, when you choose the EC2 launch type, consists of a group of EC2 instances, each of which is running an Amazon ECS container agent. Okay, kita ada ni contoh container A, container B, and then kita request untuk run 3 container A, 2 container B. So dia letak 2 dekat EC2 instance dan 1 dekat sini. Container B dekat EC2 instance yang atas dan yang satu lagi dekat dekat yang container yang bawah. So and dia letak dalam satu cluster lah. So Amazon ECS provides multiple scheduling strategies that will place containers across your clusters based on your resource needs. For example, CPU or RAM and availability requirement. So every cluster ni macam ada application dia lah. Okay. So when you create an Amazon ECS cluster, you have 3 options. Pertamanya, a networking only cluster powered by AWS Fargate. And then number 2, an EC2 Linux plus networking cluster. And number 3, an EC2 Windows plus networking cluster. So if you choose one of the 2 EC2 launch type option, you will then you will then be prompt to choose whether the cluster EC2 instance will run as an on-demand instance or a spot instance. So in addition, you will need to specify. So macam kita belajar sebelum ni, on-demand ni dia lebih dia current price kan. Dia minta apa saja dia akan dapat lah, tapi di current price. Tapi spot instance ni dia based on ada kosong tak, dia macam ada kosong tak, ada lebih tak daripada orang lain. So spot instance tu dia kadang-kadang dia boleh berhenti sendiri kan. So in addition, you will need to specify many details about the EC2 instance that will make up your cluster. So the same details that you must specify when you launch a standalone EC2 instance. So in this way, the EC2 launch type provides more granular control over the infrastructure that runs your container applications, because you manage the EC2 instance that make up the cluster. So Amazon ECS keeps track of all the CPU, memory, and other resources in your cluster. And Amazon ECS also finds the best server for your container based on your specified resource requirements. So macam contoh EC2 and then kita ada pelbagai karakteristik dan sebagainya. So senanglah bila kita ada servis ni. Dia akan buat untuk kita lah. So if you choose the first option, the networking only Fargate launch type, then the cluster that will run your containers will be managed by AWS. So with this option, you only need to package your application in containers, specify the CPU and memory requirement, define networking and IAM policies, and launch the applications. So you do not need to provision, configure, or scale the cluster. It remove the need to choose server types, decide when to scale your cluster, or optimize cluster packing. The Fargate option enables you to focus on designing and building your applications. So yang option number 1, 2, 3 tadi, 2 dengan 3 tadi dia ada EC2 instance. So yang ni bila kita pilih tu kita kena configure EC2 lah. Tapi yang nombor 1 kita tak payah fikir pasal EC2. Yang tu semua akan di-manage oleh AWS based on our setting, our recommendation, our setting configuration. So dia ada satu lagi teknologi they call Kubernetes. Kubernetes is an open source software for container orchestration. So Kubernetes can work with many containerization technologies, including Docker, because it is a popular open source project. A large community of developers and companies build extensions, integration, and plugins that keep the software relevant and new, and in-demand features are added frequently. So Docker tadi dia enable container punya teknologi. Kubernetes pula dia untuk orchestration, untuk manage Docker punya dia complement Docker lah. Okay. So Docker enables you to run multiple containers on a single OS host. Kubernetes orchestrate multiple Docker host nodes. So Kubernetes enables you to deploy and manage containerized application at scale. So nak sikit banyak semua dia boleh manage. Bila kita nak besar kita boleh manage lah. Senang untuk manage. So with Kubernetes, you can run any type of containerized application by using the same toolset in both on-premise data centers and the cloud. And Kubernetes manage a cluster of compute instance called nodes. So it runs containers on the cluster, which are based on where computer resources are available and the resource requirements of each container. So basically dia akan run atas satu clusters of compute resources. So containers are run in logical groupings called pods. So you can run and scale one or many containers together as a pod. So each pod is given an IP address and a single DNS name, domain and system name, which Kubernetes used to connect your service with each other and external traffic. A key advantage of Kubernetes is that you can use it to run your containerized application anywhere without needing to change your operational tooling. So for example, application can be moved from local on-premise development machines to production deployment in the cloud by using the same operational tooling. Semua ni nak memudahkan application lah. So dia kalau dia nak pindah, dia boleh pindah dan dia boleh guna benda yang sama. Contohnya kalau dekat data center, dekat PC, dia boleh guna automatic dekat contohnya dekat cloud tanpa perlu banyak setting. So and then you might think that you can launch one or more Amazon EC2 instance, install Docker on each instance, install cluster Kubernetes on the cluster and manage and run Kubernetes yourself. Yang tu boleh juga buat, tapi macam ni juga Amazon tu lah, Amazon dia ada apa saja ni dia akan tolong buat buat servis yang kalau semua pakai lah untuk memudahkan. So Amazon Elastic Kubernetes Service, dia ada EKS, is a managed Kubernetes service that makes it easy for you to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control plane. It is a certified Kubernetes conformant, so existing applications that run on upstream Kubernetes are compatible with Amazon EKS. So Amazon EKS automatically manage the availability and scalability of the cluster nodes that are responsible for starting and stopping containers, scheduling containers or on virtual machine, storing cluster data, and other tasks. So it automatically detects and replaces unhealthy control plane nodes for each cluster. And then you can take advantage of the performance, scale, reliability, ability of the AWS cloud, which includes AWS networking and security service like application load balancers for load distribution, IAM for role-based control, access control, and VPC for port networking. So you may be wondering why Amazon offers both Amazon ECS and Amazon EKS. So since they are both capable of orchestrating Docker containers, the reason that both service exist is to provide customer with flexible option. You can decide which option best match for your needs. So instead of kita ikutlah kita nak guna Amazon ECS atau Amazon EKS. So dia pun buat benda yang sama untuk manage containers, manage deployment, application setting, memudahkan kita lah untuk application. Okay. So kebanyakan operation banyak ada pada application lah. Okay. So ada satu lagi Amazon dipanggil Amazon Elastic Container Registry atau Amazon ECR. It's a fully managed Docker container registry that makes it easy for the developers to store, manage and deploy Docker container image. So image ni macam panggil apa, copy lah, macam ataupun blueprint kan, image. So dia bukan image yang ni, dia macam kalau dalam application ni, image ni macam blueprint lah. So it is integrated with Amazon ECS. So you can store, run and manage container images for applications that run on Amazon ECS. So specify the Amazon ECR repository in your task definition, and Amazon ECR will retrieve the appropriate image for your applications. So Amazon ECR support Docker registry HTTP API version 2, which enables you to interact with Amazon ECR by using Docker CLI commands or your preferred Docker tools. So, kebanyakan macam application ni dia banyak melibatkan dia panggil apa, protokol. So, kadang-kadang protokol tu yang penting kan. Protokol yang terbaru, updated, dia kena compatible lah dengan apa yang kita nak buat. So, kamu kena aware sebagai IT engineer ataupun cloud engineer, kamu kena aware about the protocol, updated, patch dan sebagainya tu. So, those you can maintain your existing deployment workflow and access Amazon ECR from any Docker environment, whether it is in the cloud, on premise, or on your local machines. So you can transfer your container images to and from Amazon ECS via HTTPS. Your images are also automatically encrypted at rest using Amazon S3 server-side encryption. Okay. So next is tadi kita cerita pasal containers. Kalau boleh, at least kamu dapat pick up container tu macam mana saya cerita awal tadi, macam mana dia memudahkan application lah. Instead of kita buat application and deploy pada environment yang lain, yang ni di container ni dia ambil semua yang necessary environment, dia pack sekali dengan application dan dia jadi container. Dan nak buat benda tu enable teknologi tu, dia using Docker, Docker software yang membolehkan dia buat dia buat benda ni lah, teknologi. So untuk manage Docker pula, dia akan ada ECS, container Amazon ECS dan Amazon, dan juga ada teknologi Kubernetes untuk manage Docker punya teknologi. Okay, interesting. Itu kalau nak go deep pun boleh. Sekarang tu siapa yang expert otak bidang tu memang on demand, memang masyhur. Okay, next is Amazon AWS Lambda, which is also interesting. So basically kita buat application menggunakan programming. So instead sebelum ni kita perlu ada server untuk run application. Tetapi yang untuk ni Amazon buat satu servis yang kita tak perlu fikir pasal servers. Dia akan tolong buat untuk kita. Yang kita fikir ialah tentang code application kita saja. Especially untuk developer, dia suka lah. So as you saw in the earlier section of this module, AWS offers many compute options. For example, Amazon EC2 provides a virtual machine. So yang kita awal tu kalau kita nak manage sendiri virtual machine compute service, kita nak buat contoh buat server semua tu, kita kena ada compute CPU, RAM dan sebagainya lah. So as another service, example Amazon ECS, Amazon EKS are a container-based compute service. And then, however, there is another approach to compute that does not require you to provision or manage servers. This third approach is often referred to as an serverless computing. Serverless maksudnya server tu ada, cuma kita tak manage lah. AWS tolong manage untuk kita. So AWS Lambda is an event-driven serverless compute service. Lambda enables you to run code without provisioning or managing servers. So dia calculate, okay, this code perlukan banyak mana CPU dan sebagainya. Belakang tu yang tu AWS yang fikir dan run. Kita tak perlu configure that. So you create a Lambda function, which is the AWS resource that contains the code that you upload. And then you set the Lambda function to be triggered either on schedule basis or in response to an event. So your code only runs when it is triggered. So you pay only for the compute time you consume. You are not charged when your code is not running. So upload your code, and the code you run is a Lambda function. So and then you run code on a schedule or in response to an event, and then your code runs only when it is triggered, and then kita bayar je untuk that compute time that you use. Bila dah habis compute, dia tak boleh compute, dia akan berhenti. Waktu tu kita stop, dan waktu tu kita bayar apa yang kita guna je. So with Lambda, there are no new language, tools or framework to learn. Lambda supports multiple programming language including Java, Go, PowerShell. PowerShell ni banyak Windows, Node.js, C#, Python, Ruby. So yang lain tu banyak Linux. So your code can use any library, either native or third party. So Lambda completely automates the administration. It manages all the infrastructure to run your code on highly available fault-tolerant infrastructure, which enables you to focus on building differentiate back-end services. So basically Lambda seamlessly deploy your code, does all the administration, maintenance and security patches, and provides built-in logging and monitoring through Amazon CloudWatch. And then Lambda provides a built-in fault tolerance. It maintains compute capacity across multiple availability zones in each region to help protect your code against individual machine failures or data center failures. So semua benda-benda yang kita kena set up dulu, yang kita pasal CPU apa semua nak letak kat mana apa semua, kita tak boleh fikir, yang tu semua automatic Amazon tolong buat kat kita. So there are no maintenance windows or schedule downtimes. So you can orchestrate multiple Lambda functions for complex or long-running tasks by building workflows with AWS step functions. And you use a step function to define workflows. So these workflows trigger a collection of lambda function by using sequential parallel branching and error handling steps. So with step function and Lambda, you can build a stateful, long-running process for applications and backends. So with Lambda, you pay only for the requests that are served and the compute time that is required to run your code. So billing is metered in increment of 100 milliseconds, which make it cost effective and easy to scale automatically from a few requests per day to thousands of requests per second. So kadang-kadang kita punya application, kita nak macam dia proses sikit je. Dia triggered. Okay, ada macam contohnya ada user nak perlukan something. So that triggered application untuk buat something, CPU. So CPU akan proses. So kadang-kadang sekejap je. So dia akan cost, dia akan bagi, so kita kena bayar yang sikit tu je lah, instead of nak kena bayar per hour. Walaupun kita guna hanya dalam minit atau 2 minit je. So so dia guna an events source is an AWS service or a developer created application that produce events that trigger an AWS Lambda function to run. So untuk run dia mesti ada benda yang nak trigger dia. So some service publish events to Lambda by invoking the Lambda function directly. And this service that invoke Lambda functions asynchronously include but are not limited. Contohnya kat sini ada Amazon S3, dia akan invoke Lambda, Amazon DynamoDB and so on. So Lambda can also pull resources in other service that do not publish events to Lambda. For example, Lambda can pull records from an Amazon simple queue service, SQS. uh, dia dia check tengok and run a Lambda function for each fetch message. And Lambda can similarly read events from Amazon DB. And some service such as Elastic Load Balancing, Application Load Balancer, and Amazon API Gateway can invoke your Lambda function directly. So kalau application load balancer, dia katakan dia perlu untuk balance out, so dia akan invoke Lambda function. So Amazon API Gateway, kita punya application API kan, so dia connected to Lambda function, boleh invoke directly. So you can invoke Lambda function directly with Lambda console, the Lambda API, the AWS software SDK, CLI, and AWS toolkits. AWS Lambda automatically monitors Lambda function by using Amazon CloudWatch. So to help you troubleshoot failures in a function, Lambda logs all requests that handled by your function. Okay. So remember that a Lambda function is the custom code that you write to process events. So, and that Lambda runs the Lambda function on your behalf. So when you use the AWS Management Console to create a Lambda function, you first give a function a name, then you specify you specify the run environment, ni function code, kan, and then the runtime environment, the function will use, for example, version of Python, Node.js, and execution rule to grant IAM permission to the function so that it can interact with other AWS services as necessary. Contohnya dia nak communicate dengan S3 ke, filing ke, apa semua, config service ke. So kita bagi dia access melalui execution rule. So next, after you click create function, you configure the function. Configuration includes add a trigger, and then add your function code and specify memory, and optionally specify environment variables and so on. So all of the above settings end up in Lambda deployment package, which is a zip archive that contains your function code and dependency. Okay, function code, dependency, code library, everything dia ni, and dia punya IAM. So when you use the Lambda console to alter your function, the console manage the package for you. However, you need to create a deployment package if you use the Lambda API to manage functions. So consider this example, contoh ni, consider an example use case for schedule based Lambda function. Say that you are in a station where you want to reduce your Amazon EC2 usage. Okay. Contohnya kita nak satu function yang dia boleh check Amazon EC2 ni. Dia boleh check and reduce EC2 usage. So you decide that you want to stop instance at predefined time, for example at night when no one is accessing them, and that you want to start the instance back up in the morning before the workday starts. Okay, kita nak dia stop waktu malam, dia start balik sebelum waktu bekerja. So in this situation, you could configure AWS Lambda and Amazon CloudWatch events to help you accomplish this action automatically. So here is what happened at each step in the example. For example, here in one, so you set a CloudWatch event is scheduled to run a Lambda function to stop your EC2 Elastic Compute instances at, for example, 10 PM. Contohlah pukul 10 malam kita trigger CloudWatch event untuk hantar kita invoke Lambda function trigger. Kan dalam Lambda function ni ada IAM role. Pukul 10 malam dia yang ni akan trigger Lambda function, and Lambda function akan trigger untuk stop EC2 instance. And then the EC2 instance akan masuk stop state. Kan kita belajar sebelum ni ada EC2 the stop state, pending state apa semua tu kan. Dia akan stop state. So pukul 5 pula nanti benda yang sama juga, pukul 5 dia akan hantar event triggered, and Lambda function triggered, dia akan guna IAM role dia untuk trigger EC2 instance untuk start balik. Okay. Untuk start balik benda tu. So yang ni pula contohnya macam use case for event based Lambda function. Suppose that you want to create a thumbnail for each image that is uploaded to an S3. So to build a solution, you can create a Lambda function that in Amazon S3 invokes when objects are uploaded. So then the Lambda function reads the image object from the source bucket and creates a thumbnail image in a target bucket. Here how it works. So pertamanya ada orang upload image yang masuk dalam source bucket. So anything image yang akan masuk, dia akan trigger Lambda function. So dia akan dapat execution rule untuk so Amazon S3 publish the object created event to Lambda by invoking the Lambda function and passing event data. And then they akan create a thumbnail. So based the event data that Lambda function receive, it knows the resource bucket name and object key name, and the Lambda function reads the object and creates a thumbnail by using graphic libraries and save the thumbnail to the target bucket. So yang ni source bucket, orang masukkan image masuk sini, dia trigger Lambda, dia buat thumbnail. So use Lambda function and dia masukkan thumbnail dalam target filing bucket. So AWS Lambda does have some quotas that you should know about when you create and deploy Lambda function. So soft limit per region, concurrent execution 1000, and their function and layer storage around 75 GB, and hard limits for individual function, maximum function memory allocation around 3 GB. Function timeout 15 minutes and deployment package 250 megabyte unzip. Yang ni semua limitation lah. So dia nak dia orang pun ada limitation. So untuk semua customer tu dia ada limitation untuk so for everyone lah. Okay. And then so lastly, yang ni pula last service yang dalam section sheet is AWS Elastic Beanstalk. So yang ni apa yang dia buat ialah AWS Elastic Beanstalk is another AWS compute service option It is a platform as a service. Platform as a service maksudnya apa? Maksudnya yang kita belajar sebelum ni, uh, apa ni? Software as a service, platform as a service, satu lagi. Uh, hmm, lupa dah. Okay, tak apa. Basically, platform as a service is maksudnya untuk developer. Dia developer hanya manage application. So dia tak nak manage the infrastructure. Infrastructure yang bawah tu semua dia bagi kepada AWS untuk manage, maintain dan sebagainya lah. So dia nak buat application je. So dia tak nak peduli pasal infrastructure. Infrastructure ni maksudnya compute, memori, RAM, apa semua, server tu semua dia tak peduli lah. So AWS yang manage. So AWS Elastic Beanstalk is another AWS compute service option. It's a platform as a PaaS, platform as a service that facilitate the quick deployment, scaling and management of your web applications and services. So sekarang ni dia cakap tentang web application sebab kebanyakan industri masih lagi diguna web application lah untuk industry level. So you remain in control. The entire platform is already built, and you only need to upload your code. So choose your instance type, your database, set and adjust automatically scaling. Automatic scaling, update your application, access the server log files, and enable HTTPS on the load balancer. So you upload your code and Elastic Beanstalk automatically handles the deployment from capacity provisioning, load balancing to automatically scaling and monitoring application health. At the same time, you retain full control over the AWS resources that power your application, and you can access the underlying resources at any time. So there is no additional charge for AWS Elastic Beanstalk. You pay for the AWS resources. So for example, EC2 instance run or S3 buckets, you create a store and run your application. You only pay for what you use. As you use, there are no minimum fees and no upfront commitment. So katakan application kita ni perlukan kita dah configure, kita perlukan application, contohnya application Asia punya application tu kan. Kita run code tu and dia automatically contohnya dia deploy CPU untuk that application. Dia dah tahu dekat mana region mana. And dia ada load balancer. Load balancer ni maksudnya bila orang datang ramai, dia akan channel lah ke arah ni instead of satu jalan je lah. So dia load balancekan kita punya application connection and so on. So that service yang buat automatically semua, tolong configure automatically ni, dia panggil Amazon Elastic Beanstalk ni. Yang ni free, cumanya apa yang dia configure macam EC2 ke RAM yang kita guna ke untuk apa semua tu, yang ni dia akan charge selagi kita duk guna lah. Tapi kita boleh manage. Okay. So AWS Elastic Beanstalk enables you to deploy your code through the AWS Management Console, the AWS CLI, Visual Studio, and Eclipse. So it provides all the application service that you need for your application. The only thing you must create is your code. So Elastic Beanstalk is designed to make deployment your application a quick and easy process. So Elastic Beanstalk supports a broad range of platforms. Supported platform include Docker, Go, Java, .NET, Node.js, PHP, Python, and Ruby. And AWS Elastic Beanstalk deploy your code on Apache Tomcat for Java applications, Apache HTTP server for PHP and Python applications, or Apache HTTP server for Node.js application, Passenger, Puma, and so on. So Elastic Beanstalk is a fast and simple to start using. So yang bagus tu kata Amazon dia memudahkan enable user, memudahkan end user untuk menggunakan dia punya servis. Sebab tu dia conquer cloud technology ni. So 50% cloud user menggunakan Amazon AWS cloud technology. And then use the use the AWS Management Console, Git repository, or IDE such as Eclipse. So Elastic Beanstalk automatically handles the deployment details of capacity provisioning, load balancing, automatic scaling, and monitoring application health. And then you can improve your developer productivity by focusing on writing code instead of managing and configuring servers, database, load balancers, firewalls, and networks. And AWS updates the underlying platform that runs your application with patches and updates. So Elastic Beanstalk is difficult to outgrow. With Elastic Beanstalk, your application can handle peaks in workload or traffic while minimizing your cost. So it automatically scales your application up or down based on your application specific needs by using easily adjustable automatic scaling settings. So you can use CPU utilization matrix to trigger automatic scaling option. So katakan contoh ramai orang nak pergi travel, tiba-tiba hari tu penuh. So dia akan tambah CPU sebab ramai orang masuk. So kalau tak ada orang masuk, dia akan kurangkan CPU sebab kurang orang masuk untuk guna contohnya Asia punya web application tu lah kan. So dia akan automatic, dia sepatutnya dia tak down lah. Dia automatic scaling. So you have the freedom to select the AWS resources such as EC2 instance type that are optimal for your application. So Elastic Beanstalk enable you to retain full control over the AWS resources that power your application. If you decide that you want to take over some or all of the element of your infrastructure, you can do so seamlessly by using the management capabilities that are provided by Elastic Beanstalk. So Elastic Beanstalk ni akan tolong buat automatic semua untuk infra punya provisioning. Tapi kalau kita tak puas hati apa yang dia pilih tu, kita boleh tweak, kita boleh ubah setting tu. And kita di charge based on apa yang kita guna. Okay. Okay, that's all for today. Alhamdulillah finish juga untuk yang compute service. So majority majority kebanyakan cloud ni dia based on compute lah. So sebab tu this module 6 agak panjang lah. So yang service yang related dengan service macam Kubernetes, Elastic Beanstalk, apa semua ni dia dalam batch ni lah. Okay. So if anyone have question sebelum kita close our lecture tonight. So thank you everyone for joining today. Thank you for your patience. So insyaAllah lah kita jumpa next time. Okay, thank you everyone. Have a good rest. Bye-bye.
Thank you, Doctor.
Thank you.